Also start recording. All right, so we have talked about Scoop very briefly in the first session, and we would like to go into more details about Scoop. Okay, so what is more important with Scoop is to have a hands-on exercise on this. I mean, trying it out. So, what exactly is Scoop? It's an open source tool. It extracts data from structured data source. And when I say structured, it means the SQL database. Okay. It extracts data from a structured data source into Hadoop for further processing. It can also move data from SQL database to HBase and export data back to the SQL data source. Okay, so it has something called extension framework. Okay, it has something called extension frameworks so that you can connect to any database. In case, so any of the databases that support Java driver, they will be able to, we will be able to bring the data from those sources to here. Otherwise, you can create your own connector if the driver is not available. Okay, that's it. The most simplest is if you type scoop help, it shows you all the available commands as part of scoop command, and you can see that these are the various commands available. Okay, so we will go into few of these which are important, and the rest you can explore. So before we go further, let's understand what do we mean by scoop connector. Scoop connector is a modular component that uses extension framework to enable scoop imports and exports to a data source. So by default, you do not have to work on the connector because connectors are by default enabled. It includes the connectors which are available by default are MySQL, Postgres, Oracle, and for that matter, any any database that has support for JDBC can be used with Scoop. Alright, in case your database is not one of these, okay, and neither your database supports JDBC, then you can create your own connector by implementing the connector interface. Alright, so let's take a look at a simple database. Alright, so here is the password for the for MySQL. Okay, so let me do the SSH. Alright, so the first thing we will do is we'll try to connect to MySQL. I'll ask for password. We'll enter this password. Let's check. Is it working or not working? You can see that. You can see show table, show tables, show databases, you can see there is already a database called ScoopX. Okay, we say use ScoopX and show tables, right? And select star from sales and select star from widgets. Okay, so we'll do one thing. So we are right now connected to MySQL, which is running on this IP address. The user name is scoop user, and the table name is password is this. Okay, we do not have to create this database because it's already created. We will be using ScoopX. In case you are creating a fresh new database, this is an important part to understand. This is a very important part to understand, and this is where most of the people fail. Okay, so while creating the database, make sure that your database is accessible from all the nodes. Okay, for that you need to give the permissions. Now you may ask that why should my database be accessible from all the Hadoop nodes? The reason is simple. When we import data using Scoop, it's going to use MapReduce. It's going to use MapReduce. And just give me a second. So it's going to use MapReduce. Some of the records will be imported by first node, second node, third node. So effectively, all the nodes should be able to connect to your database. And you should quickly check by logging into a couple of nodes and trying to use MySQL command. Okay, that's the most important part of it. Alright, therefore you must grant permission to all the nodes. I have given an example here. You can see that I have given the permission for all these nodes to connect to us. Alright, so Yeshi's question is Scoop doesn't need. Okay, let me just put down the question. Question is Spark doesn't need Scoop, right? Only Hadoop does. So in case of Spark, it allows directly reading the data from MySQL into something called RDD. Okay, oh, it was supposed to be 7 February. Never mind. Alright, so Spark doesn't need a Scoop. No, it doesn't. Spark has the inbuilt plugin to import and read data directly into RDD. The way we did yesterday, sc.text file. In the same way, in the same way it is in the same way it reads data from SQL. A question from Abhay is can you share Scoop user ID and password in the presentation? It's basically the database login and the password. Alright, I'm just sending it to all. Okay, so I hope everybody received it. Alright, so grant privileges is a very important aspect of Scoop. All right. So this is a sample table that we wanted to create in order to see whether we are able to import data or not. So for that, I have already created a table for you. It's the table is, but this is the same definition which I've created earlier. Okay, so we can check what is the status of the table. So the table contains three records. Widget name contains sPocket, Gizmo, and Gadget. All right. All right. Now let's try to import this table into a file. For that, let's open one more console. Okay. This console is, and let me take it out from here. Let me try to. All right. Okay. All right. So we have one terminal opened for SQL. Other I'm opening for the scoop commands. Okay. Okay. So I'm logged in now. Done. Good. So first of all, let's first check whether this command is running or not. What does this command say? It says that scoop import the database which is located at this URL. This URL contains the IP address and it also contains the database name. The table name is widgets. That's what we are trying to import. And this is the user and this is the password. All right. So let's try to import it. Let's try to import it. And I'm going to the second terminal here. And let's see what kind of error do I get. So it says that there's already a file existing at this location. So let me try to delete it. Hadoop fs minus rm minus r widgets. All right. So I've deleted it. Now let's try it again. All right. It says that the submitted job is this. Let's hope that it finishes quickly. Good. So it has retrieved three records, and you can see here the important part. You can see that it is launching the scoop command is launching a MapReduce task in order to import data. Now let's see if what happens to it. And Hadoop fs minus ls. Okay. So it has created a directory called widgets. You can see that. And inside widgets is this file that contains probably our data. You can see that it has got three records like this. All right. Now we are able to import data into the HDFS as a comma separated file. Also, notice that when you run any of these commands, scoop commands, it creates. Okay, so it would have created, what table did we import? Okay, so we imported a table called widgets, and it must have created a file for that. Yeah, there it is. Okay, so you can see widget Java code has been generated. It's basically using this class you can automate the process of importing. Okay, all right. So the first step we have been able to do is importing data from MySQL to HDFS. Okay, so first step is done, MySQL to HDFS. All right, let's try the second part. Okay, now if you have to load this data into Hive, you will have to do two things. One, create a Hive table, and then load this recently created file into into the Hive table, right? So for that, one way is you create the Hive table manually, but that's too much of work involved. So let the table be created by Scoop itself. Scoop provides you the functionality of creating the table as well. So you can see Scoop create Hive table. So this will create a table in Hive. Let's try to do it. Okay, we will leave this as such. Okay, it will take a long time. So, oh, it worked. So it says that no viable alt exception. What does it mean? It says that cannot recognize scoop. Yes, because we are trying to execute the command, a scoop command inside the Hive. Okay, so let's ask scoop to, sorry, right now first we will create a Hive table. Yes, that's right. So Abhay's question is, let me just put it here. So Abhay's question is HDFS to Hive or MySQL? It is MySQL to HDFS to Hive. Okay. Yes. All right. Yes, that's right, Abhay. Great. So we've executed this command which creates a Hive table. Okay, let's check in Hive. I have sent the command prompt Hive to the background by pressing Ctrl G, Ctrl Z, and now I'm doing FG to bring it back to the foreground. So here you can see show tables, and there is a widget table. Okay, widgets, it's already containing data. So let's drop table widgets and try to create fresh one. So we have deleted the that one, and now we are executing scoop command again. I pressed again Ctrl Z and sent Hive to the background and came back to the command prompt. Okay, so let this create Hive table create a fresh table. All right, now let's come back here and see what's going on. Select star from widgets. Okay, select star from widgets. Okay, I typed from twice. Now there is nothing in here. Next, what we can do is, since we had already created SDFS file, okay, so we have just created widgets table. Now we can just load data into widgets table, right? We can simply load data to widgets table. Okay, now let's see if it is done. Select star from widgets. Good. So we have been successfully able to import data into widgets. All right. So that's it. So we did the whole process in 2 steps. We did the whole process in 2 steps. In the first step, okay. All right. So we did. So what we did was first we copied data into HDFS, then we created a Hive table, and then we pulled the data from HDFS and loaded it into Hive table using this. So it was 3 step process. We could do the same thing in a single step. We could simply say scoop import and then give the URL, give the name of the table, and do the Hive import in a single shot. Okay, in a single shot. So let's take a look at that. Let's take a look at that. But before that, let's just drop this table. Okay. Now again back to the command prompt, and so we are saying scoop import and providing the URL and the passwords. Okay. It says that the file exists. Actually in HDFS, the file is existing. So let's just delete the file. HDFS. And then we could say rm minus r and widgets. Alright, so we have deleted our file. Next is that we will import the data into the table. Alright, so let's check if it is done. Okay, let's go to Hive. I said FG, I brought it to foreground, the Hive running so that I don't have to connect again. You can see that it has been created, the table has been created, and the data has been imported. Alright, so that was how you can import data from HDF, from MySQL to Hive. Okay, so we learned two things so far. One, how to import data from MySQL to the file system, HDFS. And second, how to import data from MySQL into Hive. Now let's move on and try to import the data into HBase. Alright, so again the same command. We are telling scoop import connect to MySQL, and alright, I'll show you. Okay, so what exactly are we doing? We are saying scoop import connect to this URL for this table, for this widgets table, and into this column family. Okay, and you can import the data directly from MySQL to HBase. All right. So there will be multiple questions at this point. Questions are, first, which column family would it go to? What if this column family does not exist? Okay, why is that question in first place? Because if you remember when we talked about HBase, HBase must have a column family. Although HBase does not have any restriction on creating columns and their data types, all it wants from you is you need to specify which column families are there in a table, as well as when you are importing data, which column family this data is going to go. The second restriction that comes from HBase is what is the column identifier? What is the row identifier? Which column contains those IDs which uniquely identify each row? And that is something you need to provide. Otherwise, it will try to pick up the rows with the column name called ID, small I and D. Okay, because these are the two restrictions imposed by HBase. First, it says that I need a column to uniquely identify each row. Second restriction from HBase is that the it needs the it needs the column family name. Therefore, we are providing the column family name. And we are also saying that the HBase row ID is this particular column called ID. All right. All right. So we go to HBase. Now we can exit Hive. We don't need it anymore. Here we are saying scoop import connect to this database and import this particular table into a column family called CF1. Okay. So it's importing the table into the HBase. Okay. Then I think parallelly we can exit from here. We don't need much. We could say HBase shell. So again, here also you can see that it's the map reduce that's getting executed and pushing data to HBase. Alright, we could see show, what was that? It was list. Okay, so you can see that there is a table called widgets. Scan single quote widgets. Just a second. Let's take a look at what exactly we did. We are saying is scoop import from this database, this particular table into widgets, and then column family is CF1. Okay, and username is this, password is this. HBase create table. It would create the HBase table, and these are the columns which we want to import. These are the columns which we want to import. Okay. Scan widgets. Alright, it's now working fine. Okay, so you can see that it has created the widgets. Okay, it has created the widgets table in HBase, which has how many rows? It has row ID 1, 2, 3, 1, 2, 3. In the column family 1, CF1, alright, just a second. I think it's still taking the old data. Let me just drop it. Okay, let's disable widgets. Okay, delete widgets. Alright, it should be there. Alright, that seems to work. Alright, let's try to import again. Alright, so you can see that it is able to import data into HBase. Alright, let's try to list and then scan. All right. So it has this time it has only one column family. Okay. And this column family has got price widget name, and so on. Only two columns have been imported other than ID. This is the ID. So ID, widget name, and price have been imported. Okay. Now let's say you wanted to push other columns into column family 2. You can execute the same command, and the beauty of this is that it will not create fresh rows. It will just update the same row IDs. Okay. Same row IDs. So you can see that not here, not here, but here. Okay. So what it's going to do is, so whenever we provide a column family name, it will put all the columns into this column family. But please note that in one command, you can only put columns into one column family. You can run the same command again with different set of columns in different column family, and it will execute. And it also takes care of if already those row IDs are existing in the HBase table. It does not create fresh new rows. Instead, it creates column families in those existing row IDs. All right. All right. Let me try to answer Mahesh's question. His first question is, could you talk a little bit about how MapReduce is executed by Scoop? Okay. Second is how it decides how many nodes to pull the data to, and the real life use case where it is used by you. Okay. So now let's talk about the first part first. So the way it works is it goes through the MySQL table or any database table and understand how many rows are there. Okay. Once that is done, then it creates the MapReduce process in such a way that few rows are imported by one mapper, and few nodes are imported. Few rows are imported by another mapper. It does not have a reducer. It only has mapper code that you must have noticed when we try to import data. When we try to import data from MySQL to HDFS, the file name contained M, not R. Okay, it was part dash M dash 00 something. So it does not have reducer, it has only the mapper. So all it does is before the process starts, it figures out which one is the ID column, and based on that, some rows are given to one node, some rows are given to another node. Sorry, it doesn't care about ID column. It basically picks up the row ID, number of rows. So first rows go to first mapper, second set of rows go to second mapper, and so on. So it divides the work into different mappers before the process is started. All right. So that was first part. Then how it decides. Okay. So this we have talked already about, and in general, it tries to use the single mapper in the beginning. But you can say, you can hear, you can see in one of the commands which we have used earlier, or in almost every command you could specify number of mappers by saying dash m 2 or dash M10 if you want to specify how many mappers do you want. Okay, so every scoop command has my m option. All right, now that is one. Then the real life uses where it is used by me. Okay, so the use case which we did earlier was in the case where we were importing data from our usual MySQL and joining it with a bigger data which is lying in HDFS. So we had two options. One, we take the data from our HDFS file into MySQL and then we do the comparison there. Our data was fairly big, so even if we imported data to MySQL and the churning at MySQL level might take a long time. So instead of that, we brought the data which was there already in MySQL into HDFS and worked upon it. So this was somewhere related to the reconciler which we were building at earlier, where we had some data already in MySQL related to the attributes of the users. Okay, so that was the okay. Next is so Mahesh's question is, does it use all nodes in cluster? By default, it uses only one, but you can say number of nodes as this, okay, by defining -m option. Another question from Mahesh is, any performance bottleneck with, okay, so Mahesh's question is, any problems with multiple nodes accessing the same table? Okay, so when SQL is accessing the MySQL table, it's reading the data. So reading is generally faster, but yes, your MySQL server will get impacted by parallel connections from these nodes. Okay, if you have defined number of mappers as 10, there'll be 10 connections to your MySQL table. Okay, I hope I'm able to answer your questions, Mahesh. All right, great, great. Let's move on. So we were able to successfully import data into HBase into two column families. And okay, so I think we have done this part as well. All right. Now let's scan the table and see what is there. That you can see that it's only having CF1 as of now. Let me just do this. So we are saying in the second command, this time import the data into CF2. That's what we are saying. Okay. All right. It's taking time. So most of the Hadoop jobs have that boot up time, and most of this time goes into preparing jobs. It works well when you have bigger data. Then this boot up time is insignificant. Now you can see that it has imported data into CF2 as well. And see, this is the CF2. Good. So we have been able to import data into multiple column families. Now we could also do the reverse. We could also take a data take some data from Hive to MySQL. Okay, so for example, let's check. This step actually creates a sales.log table in Hive first, so that we have some sample data, and then we will be able to import it. Okay, I have already created these tables, so don't have to worry about it. Now let me just check if it is already there. All right. Now let's see if it is already there. Otherwise, we will create. What was the table name? It's a sales, not sales.log. Alright, so the table is already created. Our objective right now is to take this table from Hive into, into MySQL. Okay. Now at this point of time, you will have to create a MySQL table. You'll have to create a MySQL table. Okay, let me copy the password. Alright. Now what was I trying to do? Yeah. I was trying to take the data from there to here. Alright, but before copying the data from Hive to MySQL, you'll have to create table in MySQL. That is a little tricky part, because this table, it is not created by itself. Okay, so I'm deleting the older table. Alright, so the table has been deleted. Now let's create fresh new table. Select star from sales. Alright, so it's right now empty. Now what we will do is we will import. Alright, so import and export is always with respect to Hadoop. So earlier we were importing, now we are exporting data from Hadoop side to SQL side. Alright, let's wait for a minute or so and then see what happens. It is starting to process. Alright, the work is being done. Alright, so MapReduce process has started now. So again, pushing data back from Hive to MySQL is again MapReduce process. All right, and again, you might ask that why would you need to push data back from Hive or HDFS into MySQL? So again, let me take the same example which I was talking about earlier. So once our recommendations were done, we moved data back from Hadoop to our web server, from where the recommendations were served to the end user. Okay, so in the background, we were running this batch process which was generating the recommendations. And then after generating the recommendations, we were moving data back to the MySQL server, which was there on the web server, so that we could display the recommendations to our end user. All right. So we have been able to successfully do all the things like one was MySQL to HDFS, then MySQL to HDFS to Hive, and then we talked about MySQL to directly Hive, then we talked about MySQL to HBase, and then we talked about Hive to MySQL. All right. So that's pretty much about MySQL, about Scoop. Although it's not a big deal, you could write your own MapReduce process, but why to reinvent the wheel? Because it has been tuned for performance. All right. Now this is quite interesting part. Okay. So we have got this great tool called Flume. Although we talk about Flume as if it's a brother of Scoop, but it's more like a distant cousin. It's actually a very different tool. Okay, while Scoop is kind of a batch wise, Flume is a continuous system. I'll show you. I'll give a demo. So what exactly is Flume? It's a distributed, reliable, and available system to efficiently collect aggregate, and move large data from many different sources to a centralized store. Okay, let me try to explain to you in a very plain, simple English with example. So let's say you are running a website. To run a website in production, you would have at least, and your website is quite high traffic. So you have 4 to 5 web servers parallelly running and serving the same website. Okay, some users go to first one, some users go to second one, and so on. And these 4 5 servers are continuously generating the logs. They're generating the logs continuously. Now, what do we want is we want to push all of these logs from these 4 servers continuously. As and when there is some change, you want to push that data to the central report somewhere centrally. Specifically, say you want to push the data continuously into HDFS. You want it urgently, as in you want it continuously. And that's where the Flume comes into play. So Flume is made up of 3 things: source, sink, and channel. So Flume is like a USB cable. Okay? Flume is like a USB cable which has 2 ends, one which is source and other which is sink. Okay, if you remember correctly, when if you have a power bank, right, if you have a power bank and you have this cable, when you want to charge the power bank, okay, you connect the source to it. If you want to charge mobile from it, you connect, sorry, you want to charge the power bank, you connect sink to the power bank. If you want to charge something from a power bank, you connect the source to the power bank and sink to the mobile, because you want to charge your mobile from the power bank, right? There's a same analogy with Flume as well. So Flume has got 2 ends to it: source and sink. Source is a connector and sink is also a connector. Okay, the data flows from the side of source towards the sink side. So it would be clear that if we are collecting logs in using Flume in HDFS, HDFS side is going to be the sink. There has to be a connector which is a sink, meaning which pushes data into HDFS. Okay, and the source could be anything. Now you may ask that what benefit does it bring to have this kind of modular component? Why not just have why not just have and, and why not just have a single thing? Okay, right now when you are configuring Flume process, you can configure saying you can assemble this kind of a wire. Whenever you basically set up this Flume importing, you basically kind of create this wire. You take a source, you take a sink and assemble it together, and then push, then start using it. Okay, what if we had only fixed Flume? We could have only said there is one connector which only does from local files to HDFS. Then there is another connector which picks the data from MySQL and continuously pushes it into HDFS. So, had it been this kind of monolith, there'll be too many wires required. There'll be too many wires required. Right now, given three kinds of connectors and three kinds of source and three kinds of sink, you can actually create total number of 9 types of connectivity, right? 9 kinds of imports. All right, you can imagine that you are pushing the data from Twitter, you're pushing the data from all kinds of continuous source generation into HDFS or into some other target. All right, so you can have this. Okay, so all right, now we understand that source and sink are modular, so we can configure any kind of source, and you can configure any kind of sink. Now what's the point of having this channel? What if sync is little slower, but when sync writes, it writes in bunch. So for example, sync is writing to the disk. Now disk is slower, so we write the data to sync to disk in say MB, 10 MB in a second. Okay, so the frequency at which sync is writing is different from the source, and therefore we need a buffer. Because let's say sync is producing data at 1 MB per second. Sorry, source is producing data at 1 MB per second, and sync is consuming data at 60 MB per minute. Although although average is same, but in reality, for 1 minute while source is generating data, that 60 MB data would be kept somewhere because sync is taking 1 minute to write. Okay, while source is reading 1 MB per second, sync is writing 60 MB in a minute. It's taking 1 minute to write. For that 1 minute, where will the data stay? And that's where the channel comes into play. So you could define different kind of channels, and you could define the buffer size of each channel. All right. So this would make sure that you could build really modular components that could keep on pushing the data to a central place. All right. So the other important part to understand about Flume is you could connect such kind of pipes together and make this wonderful grid or mesh of all these pipes. Okay. And that could solve a lot of problems. All right, so one sync can write to another source. Okay, and a sync could write to multiple sources. So this kind of flexibility is provided by Flume. Flume supports large variety of sources, including tail minus f. So what does tail minus f? Tail minus f changes a file. Okay, as and when new lines are being written to the file, tail minus f keeps on reading those newly added lines into the file. Okay, while tail only gives last 10 lines and then exits. Tail minus f is a continuous process. Similarly, Flume is a continuous process. It keeps running for years or months. Okay, it will basically keep reading from sources when pushing to the sink. If source is empty, it will wait for source, and if channel is full, then again it will wait for the data to be written. Okay, so that's how the Flume makes it possible to run it continuously for years. Okay, other example is syslog, log4j, and so on. Okay, also Flume nodes could be arranged in an arbitrary topology. Typically, there is a node running on each source machine, and with the tiers of aggregating node, the data flows through in this way to on its way to HDFS. So you could combine the Flume network so that the data flows from one end to another. You could create the best effort delivery, meaning a delivery which does not tolerate any node failure. Also, you could create a composition which is end to end, which guarantees the delivery even if node failure is there. All right, so let's take an example of how does this Flume work. First, we will be creating a single configuration file. So, all right, let me take give a quick overview. So, if you have, say, 10 nodes, 10 computers on which the web server is continuously producing some data, and we want to push this data into HDFS, which is central at a single place. So, what you do is you first create agent. Okay, you create the configuration of each agent, and then you run the agent. Okay, an agent is nothing but a small process running on each node, listening to the source and putting the data into the sink. That is an agent. So we'll be creating the configuration file for agent. Okay, so first of all, we define the name of the components in this agent. Say a dot sources are r1, a dot sinks are s1, and a dot channels are c1. I mean, not a but a1. So if you have many agents, just put all the configuration of all the agents into the single file. Okay, and while starting the agent, you provide this configuration file and also give the name to it. And accordingly, that particular agent will only be picking those configuration values. So here we are saying that A1's sources are R1, and R1's type is netcat. Netcat is NC, which means it will read from a socket. Okay, so we are saying that listen to this particular socket, and we will be producing data over there. Next is describe the sink. We will be pushing the data which it listens on the socket into HDFS continuously. So we have to provide a location where it would be pushing the data. All right, and okay. Also, we have to define what kind of channel is it. So we define source. Our source is the network port. Sink is HDFS, and the channel is in memory. Okay, the channel is in memory. All right, so it binds the source and the sink to the channel. All right, All right. So it first it informed agent about its source, sink, and channel. Then we informed the sources about the channel and sinks about the channel. No, there are only one sink called S1 right now. If there are two sinks, let's say S1 and S2, you could say A1 dot sink equals to S1 comma S2. Okay? And here, while defining that, you could define things like here. Okay, you could say S2, S2, and this. Okay, this way there are two sinks, although both of them are writing to HDFS. Yeah, but it's only. Is that your question? Yes. Okay, there are, yeah, I think let me just go through the questions. There are some questions. Can we say Flume used to transfer unstructured data? Yes, it can transfer any kind of data, structured or unstructured, although it's generally used for unstructured data. So, yes, we can say that. All right. Abhay's question is, what about the other sources like tail, syslog? Right now we are only taking an example. So what do you mean by other syslogs? So you want more description about them? Syslog is Unix syslog. So in Unix, there is something called syslog. Okay, let's say you want to monitor the health of all of your cluster. So you could basically use a syslog monitor, and syslog will read the system logs and push it to HDFS, push to the destination. Log4j is the log file where it generates the Java kind of logs, and you can use that also. There are a wide variety of the sources. Okay, there are many more sources. Here we have just listed few. Okay, now once we have defined all of this, then we can go ahead and start Flume agent everywhere. Okay, Flume agent, and please note that to the Flume agent we are saying that this is our config file. Okay, we are saying that this is our config file, and this particular agent is what we are trying to start, so that the overall idea is to keep a single configuration file, and not have many configuration file, single configuration file but different sections, some for A1, some for A2, some for A3. All right, a question from Biswa. When when one flume When one flume is connected to another flume, does the sink of first writes to the data to the disk, and source of the second reads from the disk? No, it directly writes to the destination. Okay, so your second assumption is correct. It sync simply connects to the second's source and then deliver the data. Okay, the if you want kind of a fail safe, what you can do is you can the make the channel as persistent. So Mamta's question is, in what units is the capacity? The capacity is in the just a second. Where is the capacity? Yeah, transaction capacity is basically the number of packets that it needs to keep. Okay, the number of packets it needs to keep after this capacity has reached, it will basically pause the producer. All right, next is Let me just read more questions. Is sync.k1 a mistake? Let me see which, did I make a mistake here? Syncs. Yeah, this is commented out. This is commented out. Okay. All right. Mahesh's question is it only used to for transfer of data or any other action? It is just used for continuous transfer. Continuous transfer. All right. There are many more sources. One source we'll be using Abhay is the network one, NC. Okay, and there are more. You can just check their website. I'll, I think I would have kept a link somewhere. There are many more sources, and they keep on adding from one time to another. All right. So let me try to answer Yash. So Yash's question was, what if there are two sinks? Okay, how would we have this? So you could basically, while defining sinks in case of A1, you could say S1 comma S2, and again we could define the data for S2. Okay, the target for S2, we could say that the S2 is, say, the what do you say, JDBC. Okay, and we could also define the, here we will provide the information about the connection. Okay, we could provide information about connection. All right, and so on. So in that case, every sync, the every agent will be writing to two syncs. The A1 agent will be writing to S1 as well as S2 parallelly. Now question is, why do you need this? Why do you need to chain Flume agents? The objective of chaining Flume agents is that basically you could create complex topologies. Okay? Alright? There are many more use cases. If you think about it, you could create complex mesh of the agents and get the work done. All right. So was he able to answer Yash? No. Abhay, Mahesh, Mamta. All right. Moving on. So let's have a look at the demo of Flume. Okay. Let's go into my account here. No, it got exited. So here we are. All right. Now let's first of all we will try to download this particular file. It's already also in the folder called data/flume. Okay, it has to be copied to the local drive. All right, it has to be copied to the local drive. So you could say Hadoop fs-ls data/flume, and here do we have flume? Okay, we don't. So I will just check what's with the, I could say Hadoop fs minus copy to local. So it must have created a Flume folder. Now inside Flume we have this conf folder. Inside conf we have Flume properties. In this Flume properties, although the names are different, but the idea is same. Okay. let me change this cluster destination. Okay, so we are saying HDFS h1.cloudxlab. Okay, and you can see here clearly that first we have defined everything is associated with a particular agent. Okay, that's important thing to understand, because if you have many more agents, it would be easier if we could just define in a single configuration file. All right, now what we are saying is listen to netcat at this port. All right, so let's try to execute this. Let's try to execute this by following this. Okay, take I'm going one step up. All right, so it must have started. You can see the sync the sync has been started HDFS1, and the source has also been started. Okay, it says that it is running on this particular port. Now one more let's open one more H5. Okay, you can see that. All right, so now we will connect to 127, which is localhost, and we will talk to this particular port, not this, one more four. Okay, all right, so one more thing let's open is see whether the data is going to the destination or not. Okay, and what was the location we gave? What was the location in our config file? The location was, okay, the location was, let me just check the location first. Conf flume dot properties. It is inside user student, which is wrong. Ideally, I should just cancel it. The location that does not exist will not work. Okay, I will put my login ID. And what is my login? This is 9034. Okay, so instead of student, I'll write my login ID. Okay, so I have to provide this, and let me just put it in something called Flume Web Data. Sounds good to you? All right, now we run it again. All right, now we connect to this port. Good. So we have written some data and it shows that it's creating this particular temporary file. Let's check what's happening with this temporary file. Okay, so we go to Hue, enter the login password. I think it's already in my account. And there you will see Flume Web Data. Okay, so let's sort it by date. Where is the, where did it create this? It's saying that callable timeout h1 dot cloudxlab and flume dash web data. Do I need to create, let me just try to create this folder. Alright, let's just try to create this folder. Okay, so we are inside user Sandeep Giri 9034. Alright, why is not working correctly? Did it work? Let's just see if, no, it says that unable to sync. Okay, alright, it's not stopping. So Flume Web Data, Mamta, is something I created in order to, alright, it always works. Just this for the first time, it's not letting me connect. Yesterday also, let me just kill it. Alright, so what we will do is we will try to change the Flume properties files so that okay, will it work? Let's just see. Alright, will this work this time or again? Okay, so let me just see if the file is being created. Yes, this time it's getting created. So instead of specifying the URL, I have put the only the absolute path. Okay, so I've not specified the IP address or the domain name, and then it's able to write the data directly to HDFS. Okay, so the data is being created continuously into this folder. Okay, I'll show you. Let's try to write some more data. Okay, let's try to generate a little bigger data, and here we go. Okay, so this time we are generating really huge data, and it's going to overload HDFS really well. See the files, number of files we are creating per second. Okay, you can see this, and yeah, by now it would have created thousands of files. All right, you can see there are 6 pages right now. So all I was trying to say is that we could generate quite huge data. Okay, right now this guy is generating only y continuously, and this is a binary data. You could write a program which reads the byte writable and read it. Okay, so that's it. All right, so that's how the Flume works. All right, that's how the Flume works. So we were able to generate humongous data. You can see 12 pages of uh, file list, and each file containing many Ys. Okay, so in the same way, so the idea was to just prove that Flume can consume data at a really fast pace. All right, so let's take a break for 10 minutes, and then back by 8:40 a.m. IST. All right. So let's start with our. All right. So let's start with our rest of the discussion. Is everybody back? Should we start now? Yeah. Good. Good. So let's start now. All right. So our next point, next discussion topic is Uzi. All right. So Uzi is a workflow scheduler system to manage Apache Hadoop jobs. Okay. So it's basically a scheduler system which helps you manage Apache Hadoop jobs. And workflow jobs are directed acyclic graph. What is directed acyclic graph? Where we have a dependency, when we have a dependency tree. Okay, we have a dependency graph, you can say. A depends on B, depends on C, and so on. When A depends on B does not mean that B also depends on A, and therefore it's not, it's directed. Okay, it's always directed who depends on who, as well as it's acyclical. Acyclical means there should not be a cycle, there should not be a scenario where A depends on B depends on A. Okay, otherwise you will never reach to a conclusion, you will never be able to finish the job, it will be infinite job. So workflow jobs are directed acyclic graph. Coordinator jobs are recurrent. Oozy workflow jobs triggered by time and data availability. So there is something called coordinator. So one part of Oozy is to execute job given the XML file. Okay, and this XML file contains the description of jobs and how, in what manner they need to be executed. Okay, and there is another part called coordinator. What does coordinator do? Coordinator basically execute your script automatically at a scheduled frequency. Okay, at a scheduled frequency or data availability, you could also say whenever data is available in this folder, execute this job. Okay, and Oozy is integrated with the rest of the Hadoop stack, meaning via Oozy you could execute pig script, you could execute hive script, you could execute Hadoop HDFS commands, you could execute MapReduce, and so on. It's a scalable, reliable, and extensible system for executing the workflows. All right. So first, let's understand what we mean by DAG. DAG is basically an acyclic graph. Now here you can say the job number 5 depends on 11, depends on 10, 11 depends on 10 and 9 and 2. Okay. So before 5 get executed, 9, 10 and 2 will get executed, and then 11 get executed, and then the 5 will get executed. Similarly, job number 7 is dependent on 11 and 8. Okay, now you can see that there are no cycles in this. So DAG is a very important phenomena in computing. DAG is very important because DAG is everywhere. Okay, directed acyclic graph is everywhere. You get up in the morning for the office, the things you do are actually kind of a DAG. So to go to office, you need to get ready, and what do we mean by get ready? Get ready includes many things such as wearing shoes, wearing shirt, wearing coat, wearing uh, whatever, and all of those things, they all depend on you taking bath. So if you draw the graph, or if you have a project plan, in the project plan as well, all the things that need to be done are a directed acyclic graph. Similarly, in case of pig, dataset A, B, C, D, whatever we were defining, A depends on B, depends on C, and so on. All of those datasets were forming directed acyclic graph. Similarly, in case of Spark, which we discussed yesterday, the it was a it was it was a DAG. All right. So let's take a case of we'll talk about Mahat in a bit while, but before that, so when we generate recommendation, we we have some data from Apache logs. We need to clean up that data and feed to Mahat, and whatever are the results of Mahat, we want to use Scoop to push that data to we want to push that data to web server. Okay, so pig using pig we can load flume logs. Okay, so first flume gets executed, which is get loading the logs, and then using scoop we loaded dictionary file from somewhere, and then we combined the data and cleaned the data, and after we have cleaned the data we will feed it to Mahat and so on. Now there are too many things to be done, and these kind of things can be well done using Uzi. Okay, this is a very quick view of how does Uzi workflow look like. It's essentially a workflow. Each individual work is defined by start and end and what happens when it get killed. Okay, let me just take it in a separate window. Okay, let's see here. Okay, so this is our workflow XML. This is our workflow XML, and in this workflow XML you could see each action there is basically made up of many actions, and inside an action you have what kind of action are you trying to execute and what happens when it successfully completes or what happens when it get killed. And the action, there are many kind of actions including MapReduce, Pig, Hive, Scoop, and so on. And this MapReduce is basically taking the location of the job tracker. Where is your job tracker? Second is asking for the name node. Okay, so we need to provide these two information. Now instead of hard coding the values, we are passing it via something called properties, and these are extra properties. Okay, meaning what is our mapper class, what is my reducer class, where is the input directory, where is the output directory. Okay, so this is what we have as a workflow. All right, now we could join multiple actions together. We could say first action, and then we could fork it, and then second and third, and then we could join them and give the final result, as you can see here in this case. Okay, in this case, as you can see here. Okay, so what exactly are we doing here is we are defining a start job. So this is my first job which gets executed, and then you have second job. Okay, and there is a fork job. So the first job sends work to the fork, and fork sends work to second and third. Okay, and second and third gets executed parallelly. Okay, they have both are right now map reduce job, and then final job is there. This final job basically joins both the things, because second job also leads to join, third job also leads to join, and here we are defining join as final job. Okay, that's it. So this way we can define the order of things sequentially. Yes. So yesterday's question is, so if we have some more classes like like partitioner, combiner, etc. You can define all of those here. Okay, good. Very good question. So let's try to run a couple of examples and let's try to. Yes, yes, we have an interface, but I would strongly recommend that you try from the command line. Okay, because in a larger project, running, running the things from the command line is better. All right, I'll show you how to do pig and hive as well as how to avoid how not to remember these XML. Okay, all right, all right. So for running the example, you can find this Uzi examples folder. This is a very nice zip file. You should generally, I mean, this is a good place to start. Okay, this is a good place to start. Okay, let's say Hadoop FS, not this. Find, okay, find, okay. So we have Uzi examples folder here. So Uzi examples tar minus ZXVF Uzi. Where is it? Isn't this the same folder as mine? Oh, oh. So we could say cd Uzi examples. Okay, tar ZXVF Uzi examples. So we have examples folder here. Inside this examples you have, so generally whenever you are building the full-fledged Hadoop project, this is what you're going to do. You create a folder that contains src, input data, and apps. Okay, I'll explain to you what this mean. So inside the src you put all your Java code. This one contains all your Java code. If you see, this contains all your Java code. Okay, and inside input data you put all your raw data. Okay, generally, and these examples will not be in the local folder, it'll go in the hdfs. Okay, then you have apps folder. Apps folder is something which assembles everything. Yes, apps folder contains the workflow. Okay, so you can see that there is, for every kind of work there is a workflow xml, and you can see that it also contains your jar. So you compile your src, create the jar, put it in apps folder. Let's take a MapReduce example. So here you can see that we have workflow.xml, we have job.properties, and we have lib. Okay, what does lib contain? Lib contains the compiled version of src folder. Okay, it's a compiled and bundled version of src folder. All right, and this workflow, if you see what is there inside the workflow, okay, what is there inside the workflow, you can see it contains exactly the same thing what we have defined. Now you must be wondering, where is this dollar job tracker coming from? That's coming from job properties. Okay, that's coming from job properties. Okay, it defines name node, job tracker, and so on. All right. Now let's try to. So, so let me just put a.cloudxlab.com, a.cloudxlab.com, and here also I'll put a dot. So you only have to keep this job properties with you. Rest goes in the HDFS. Okay. So I could copy job properties somewhere. All right. So, all right, good. So we were able to go through the Uzi examples. Now we have extracted it. Let's copy examples folder. Okay. Hadoop fs minus rmr examples. Let me delete the old one. Okay. Copy the new one. Not like this. Go up. Now let's edit this particular file. Okay, so you can see this. All right. Now, now we could say we could basically give the IP address of the node that contains Uzi. This is the IP address of the node that contains Uzi, and we can log in. We can use that and execute. Let's try to execute. All right. We have already modified this job.properties. Let's see if it runs. Okay. All right. It's trying to contact that particular node. All right. Doesn't seem to work. So these are the local IP addresses, and that's what I want to test it out. Looks like this one will work. Let's try again. Let me edit it here. All right. So once it's able to connect this particular IP address, then everything will work fine. For some reason, it's taking a long time. All right, I'll take a look at it. Mostly this generally works, and yeah. All right, and basically it schedules the job and make it execute. All right, so I've just put debug into it. Also, for the same thing, whatever we are doing here, you could also execute from here. You could go to workflows, and you could go to, okay, so you could create your own workflow from here. Okay, you can do many complex things. You could just rename it first. So let's say you are looking forward for executing a pig script. You'll just drag and drop pig script, and here you could a file, upload your pig script here somewhere, and then use that one. Okay, I'm using this example here, say pig example, and okay, so this is my pig script. All right, so the input goes to the pig script, and then these are the parameters, okay, which you can pass to to pig script. Remember our pig, the arguments we talked about, the same argument. Now let's say parallel to pig, you want to execute a hive also. So you could basically take, um, or maybe before this, you want to execute, say, scoop program. Okay, this is my scoop program which will import data from MySQL to HDFS. Parallel to scoop, I want to say run Hive. Where is Hive? Hive script, Hive to script. Okay, so parallel to this, I want to run Hive. Okay, where did it go? So path to the script, I could go to my script folder and define the script location. Okay, so I'm just selecting some script. Okay, and refer to the hive site.xml. Okay, so we have to specify hive site XML. Okay, that you can either pick from here for time being. Okay, so now what does it show? It shows that initially, as soon as program starts, it will start scoop and hive in parallel. Okay, or maybe some other task. And once both of these are done, then the pig script gets executed and so on. And once everything is done, you could execute You could execute the the actions like map reduce job. Where is the map reduce? Yeah. Okay, this is my map reduce job. Where did it go? Okay, so where is my map reduce job? Here. Yes. So we are saying go to my jar folder and let's say where is my map reduce? Inside this. Okay, so this way I can create the full workflow and make it run. Okay, let's just save it and execute it. All right. All right, so let it execute. Although we have just filled in some random data, we have not even planned for this. Okay, so it will execute the Uzi job. So you can see that from the UI, it is very easy to create a great workflow. You can see it's very easy to create a full XML. You don't have to code anything. All right, so this way you can execute your Uzi commands. All right, next we want to talk about is Mahat. All right. Okay, so what is Mahat? Mahat is a machine learning library which is built on top of Hadoop, although it's being rewritten for Spark, but the theory remains the same. Okay, so it's basically a machine learning library. It's written based on a paper by NG and uh, and NG ETL that MapReduce for machine learning on multicore. It started as a Lucene sub-project, became the Apache top-level project in April 2010, and then okay, and literally the meaning of Mahat is comes from Hindi. It means a keeper or the driver of the elephants. All right, so what exactly is machine learning? Machine learning is to programming computers to optimize the performance using example data or past experience. Okay, so in very simple words, if I give you two data points x and y, or I give you an Excel sheet containing x and y, right? Two things. Okay, because of the temperature, outside my room, the temperature inside my room was this. These are the two temperatures I'm giving you. Now, if you plot a graph using these two temperatures, you will be able to extrapolate and predict that what will be the temperature of inside my room when the temperature outside the room is something. Okay, so this is most rudimentary form of machine learning, where there are two variables. Based on one variable, we are doing the prediction of another if we have the past data. What if we have three variables? We have four variables and five variables. Okay, or maybe thousand variables. Okay, given these thousands input variable, this is the output, and there are millions of such records given to you. Okay, and based on this historical relationship between these variables, you have to predict the future. And that's what is machine learning about. Unlike the robotics or AI, here we are talking strictly in terms of empirical data, and you'll be amazed at what all could be achieved with this. Okay, For example, take a look at this particular video. Take a look at this particular video by Mario. Okay, all right. Now look at this video. So this is this guy, this researcher has created one one tool, one kind of a machine learning application which learns any game played on NES. How many of you have played Mario in past? Has anybody played Mario? So Mamta has played, Abhay has played. Okay. Okay, those who can't recollect Mario, Mario looks like this. I'll show you. Now, can you recollect? Great. So in I'll give you this video link. You must watch it in your free time. Okay. So what he did was a very simple thing. He created a program which learns by observing Mario. And he does not observe the photos. He just observes the memory. Okay. The program observes the memory that this is the input, this is the environment, and when I pressed left, then the score went down. When I pressed right, the score went up. So it created lots and lots of data set by observing and randomly pressing keys. So he wrote a program which would observe the score and observe the memory and try to press random keys and then understand which one gives him better score. Okay, so the input is just some memory data, random memory data, and the target is to achieve the maximum score. And you will be amazed at what all could be done. You will be amazed at what all could be done. At the end of this, the Mario was able to this program was able to play Mario so well. Okay, this is something which he is playing, not Mario. This is the beginning of his game. So right now it's not doing anything, it's just standing there, and it's just standing there, and yeah, now it's able to play. I'll show you. Go back. Yeah, see here the Mario is just standing and it's learning. It's a beginning phase. So this is the beginning phase where the program is just trying to learn what's going on. Okay, for example, here it's hardly able to get out. Okay, now slowly as it goes forward, it starts to learn really fast. See see it's okay. So the program, just based on numbers, has figured out the game, although it's not playing really well right now, but yeah, it's able to do a decent job. But as we go forward, you will be amazed at the amount of learning it does. In a week's time of continuously playing this game over and over again, this machine learning algorithm masters this game. And you'll be amazed at the level it has got. Look at this scene. Okay? Look at that. So what he has done, he has figured out bugs in Mario game. The program, the software has started playing the game so well that it has figured out the bugs that even if a Goomba hits it from the top, still it wins. It has figured out that in case it hits Goomba from the bottom, and the moment the Goomba starts coming, it starts moving down. Similarly, he was able to train the game to play, train the application to play many games. So Yes's question is, can we teach stock trading with this? Yes, you can. And many people are already doing this. All right? Did it make sense to you? So basically, it looks like magic that a computer application is able to play games better than us by learning by itself. Nobody taught this program to play Mario. All the game was taught how to learn. That's it. All right? Do watch it in your free time. So that's a great example of machine learning. And the amazing part is that most of this is very much available for free. You do not have to buy anything. All right? So machine learning is of three types. One is called supervised, unsupervised, and semi-supervised. Supervised means we know clearly that this is the input, this is the output, and we want to clearly label things. Okay, unsupervised is we have no labeling, and the problems that lie under unsupervised learning is, given these emails, can you categorize them into four buckets, four any kind of buckets? And semi-supervised is where you have some labels and there is no label available for any data. Okay, there are many applications of machine learning, not only limited to these, but many. Machine learning could be applied anywhere where writing the algorithm is difficult, or where you have humongous data available. So data wins over the intelligence. Meaning, if you are really clever and you write a great algorithm, okay, and I'm not so clever, I just looked at millions of records and figured out the pattern, then chances are that my algorithm would be better than anybody else if I've interpreted the data correctly. Okay, so there are many more use cases other than these standard ones. Okay, recommending friends, giving dates, and so on. All right. Now there are different kind of machine learning tools. There are different kind of machine learning tools. So it starts with our day zero, when we started to plot graphs. Okay, so when we have few records, or maybe 10 to 20 records, we could just plot the graph on a paper or a whiteboard and then reach to a conclusion and start predicting. If the data grows beyond few lines, it goes into MBs, then you need MATLAB, R, or Octave for both analysis and visualization. But if if your data goes into lower GBs, if the data goes into lower gigabytes, then for analysis and visualization, you need two different kind of tools. You need two different kind of tools. For analysis, you need NumPy, SciPy, Veka, and for visualization, you need tools like Flare. But when the data grows beyond gigabytes, it goes beyond gigabytes, then the problem starts. Because if it goes into beyond gigabytes, then it won't fit into the memory, and you won't be able to get it done through a normal system. At that point of time, you would have to go with Mahout, Giraffe, MLlib, SparkR, or Spark GraphX. Okay, so these are the various libraries, and out of this, Mahout is the most simple to use. Although, as of today, the Graph and GraphX are also doing good. So GraphX is something you may also like to take a look after Mahout. All right. So there are many use cases of Mahout. One is collaborative filtering. So what is Mahout? Mahout is a library which internally uses MapReduce and give you the results. And what kind of algorithm does it have? First one is collaborative filtering. What does it mean by collaborative filtering? Collaborative filtering is a technical name for recommendation generation. What is recommendation generation? Given the set of movies and my ratings, can you tell me what kind of movies would I like? Second is clustering. Clustering is given emails of all the people, or given the properties of all the cars in the world, can you prepare a chart in which the cars which are closer to each other, the cars which are closer to each other are on the same node? Okay, that is clustering. Classification. Classification is another use case for Mahat. Given lot of records, like these are for the records with these property go into first bucket, the records which these property is spam, records with these property are not spam. So that is classification. Then fourth one is frequent item list mining. What does it mean? The items which are sold together should be displayed to the user. That's what is frequent item list mining. So let's take a look at the recommendation example of Mahat. Okay, so what we need to do is, given these three column data, we need to feed to Mahat. Mahat wants three column data. First one is the product ID, then first one is person ID, then product ID, and the rating. The rating has to be from 0 to 5, and product ID and the person ID has to be long. Okay, it cannot be string. And other than the input data, you have to specify which algorithm do you want. In most of the cases, log likelihood will do a great job, but there are many more. You could try all of them. Okay, so let's try to do this. First, you download this data. For me, it's already downloaded and is also available. It is also available in Hadoop fs-ls. Okay, looks like it's not. Okay, I already have this data here. Okay, so the question here is, let's understand the problem. Okay, so if you look at this data, okay, let me try to answer Yes's question. Okay, so what he's asking for the interpretation of the output, you can take a look. What I wanted to show you is Sandeep liked Matrix this much, Sandeep liked Casablanca this much, Kumar liked Matrix this much, and Kumar likes Shawshank Redemption this much. Now, based on this, is trying to cross-sell Kumar Casablanca and Sandeep Shawshank Redemption. Okay, because looks like Sandeep and Kumar are very similar to each other, and therefore it has given this recommendation. All right, that's what is the recommendation all about. So for now, let's download this data. I have already downloaded it, and it would be there in my folder, so you can see. All right, not this one I want. So I could say Hadoop fs minus ls slash data, and under this you have ml dash 1m. Okay, now here you see there are how many files. Readme is there. Readme tells you what is there inside this folder. Okay, a better thing would be to go to the file browser here. That'll be easier for all of us. So you could simply say go to slash data slash ml. Okay, ouch. So here you can see the README. README tells you about the details about this data. I've downloaded this data from Movie Lens website. Okay, so it tells you the information about everything. Okay, then you have movies.dat. What does movies.dat contains? It contains the information about movies. Here ratings.cadet contains the ratings given by the users to the movies. Okay, it shows that user number 1 has rated 1193 movie as 5 out of 5. Okay, at this particular time. This is what it is. The data is separated by double column, and first column is the user ID, second column is the movie ID, and third column is the rating, and fourth column is the timestamp. Timestamp since epoch, which is 1st January 1970. Okay, so it has created this. We have this data, but the problem is, Mahat says that I want the input to be comma separated. Now, how would you convert it into comma separated? Anybody? Quickly, first answer. Yes. So yes says use regex, but with what? With pig, with normal SED. What should I do? Note that this ratings.dat might be a really big file. Right now it's only 23 MB, but tomorrow it might be 23 gigabytes. Yeah, good. Let's use pig for this. All right. We could simply use this Unix command. Okay, but for that first you have to bring the data from HDFS to local and then something else. Okay, instead of that, let's use pig to load the data first, separated by single colon. Now, since we are separating by the single colon instead of double colon, then we have to ignore the blanks because the data is separated by double colon. So $1 is going to be blank, $3 is going to be blank. All right, the output directory already exists. Okay, let's just create another output directory, or maybe delete delete ratings.csv. All right, there you go. It's creating my folder in my home directory. Okay, so take a look at what we are doing. First, we loaded the data into RD. Then we iterated over RD and picked up only these columns, and then we stored it somewhere. Okay, so we have, so it must have created a folder, you see. You can see that. This is the comma separated values now prepared, which can be given to Mahat. Okay, it's a big mistake I have made. I've tried to read the data, which is really huge. All right, let me just close it. Will you use it? Okay, now we are done with preparing the comma separate files, and we have already uploaded it there, so no need to copy. And then we have to delete the old data which is existing on the server. Okay, so we have deleted the data. Next, what we have to do is describe Java Home, because that's what Mahat depends upon. And then we say Mahat recommend item based, which means please generate recommendations for us. And using this particular algorithm, this is my input folder and this is my output folder. Okay, don't get confused by .csv extension, it's a folder. Yes, great. Thank you, Midli, Mahesh, Vishwa, and everybody who answered my earlier question. I did not see your answers. Okay. So Abhay is saying, where is log likelihood? You see that? Here we are saying that minus s log likelihood. It's a part of the package, part of Mahat. Okay, it's part of Mahat which is available. Good. So it's generating the output. And once it's done, it will create a folder called records, and under that there'll be part 00 something. All right. These are the various other algorithms which are available. All right. So assignment for all of you is import data from MySQL to Hive and back. Build a Oozie job for the fourth problem, which is the voting problem of session 2. Okay. Prepare movie recommendation for yourself using your own data, combining with group lens. Okay. So these are the assignment for today. All right. By the time, because it's going to take at least 15 minutes to finish this work, so we will let it run for 15 minutes while we discuss rest of the things. Okay. So yes, okay. Okay, let me take a look with you. Okay, let's have a yeah. Let me take a look at it. Okay, I was waiting for some team member to finish that one. I think they are also stuck. All right. So I'll take a look at that one and then we'll see. All right, Yash. Good. Now the session number 10. So we discussed till Spark and the streaming. All right. So we talked about Flume, Oozie, Scoop, and then we talked about Mahat. All right. Question from Yash is, how does movie recommendation work? There are many algorithms and we are just using the log likelihood. Okay. The one which is Tanimoto coefficient, Okay, so let me explain to you. Basically, the way these algorithms work is by bringing or by predicting which users are similar to each other, and then start recommending each other's movie. Okay, so first they try to figure out which users are most similar to each other, and then start giving recommendations to each other. Okay, similarity data is like this. I'll show you. Okay, his question is, where is the similarity data in here? I'll show you what do I mean. Okay, you see ratings.csv here. Inside it, you see user 1 and some other user, say user 2. Okay, user 1 has watched these movies and user 2 has watched some other movies. Okay, now if user 1 and user 2, for user 1 and user 2, you compute the intersection. How many movies are there in common and how many movies are differing? Okay, and that index, if you divide the two, number of movies which are similar divide by number of movies which are different, that number is defining the similarity index between user 1 and user 2. All right, so Mahat will first compute the similarity index between every user. Okay, so it will compute a matrix of, say say 1000 by 1000 if there are 1000 users, and so on. Okay, does it make sense to you? All right, so there are many different strategies. I've just outlined only one strategy. Okay, now I would let it finish. Okay, all right, it says the output folder already exists. Which output folder? Oh, I get it. All right. So this way we can generate the recommendation, and once recommendation generated, it'll show you this kind of data. For this user ID, these are the recommendation. This one has got 5 out of 5 recommendation, meaning this is highly recommended. Had it been say 4.5, this one, this could have been less. Okay. So this way it's giving the recommendation in clear form. All right. All right. So yesterday we talked about streaming. Okay. Yesterday we talked about Spark streaming, whereby uh, we were showing you that it counts number of yes, or we actually, yeah, we did not do that. I'll send you the recorded session for that. Okay. So conceptually, we went through the Spark streaming, which basically does the computation per second or per minute in a real time. Okay. On the similar line, there is Apache Storm. Apache Storm is pretty fast. It is just that it's a different kind of system. It is only designed for streaming. Okay. It's only designed for streaming, and if you need the output lesser than 1 second, If you want to do the computation where you need the output in lesser than 1 second, you go with the Storm. Otherwise, Spark does a good job. That is the conclusion of the two. So Apache Storm is a distributed real-time computation system. It is very similar to Spark streaming. It can reliably process unbounded streams of data, meaning which is not going to finish, it's going to come forever. It can be used with any language. It is fast. It has been benchmarked over 1 million tuples per second per node. Okay, it's highly scalable, highly fault tolerant, and guarantees that your data will be processed. Integrates with queuing technologies and database technology. So Apache Storm is a dedicated system for stream processing, while Spark streaming is just one use case of Spark. Apache Storm is quite reliable. It, it is used for real-time analytics, continuous computation, distributed RPC, and ETL, and online machine learning. And there are many companies which are already using it. So the processing model of Storm is record at a time, and Spark creates these mini batches. Okay, latency in case of Storm is sub-second. Okay, sub-second means fraction of a second, and in case of Spark, it's few seconds. And in case of Storm, the fault tolerance is there. At least one record will be processed once. There may be duplicates. In case of Spark streaming, it's exactly once. And the implementation programming API of Storm and Spark are as follows. The origin of Storm was at Twitter. That time, Twitter was called Backtype, and then Spark was created at UC Berkeley. So Storm was created by in Closure, while Spark was created in Scala. API in case of Storm is in Java and others. In case of Spark, it's Scala, Java, and now Python too. All right. So Spark streaming is well integrated with a batch framework called Spark, but Storm does not have such integration. Okay. So while Storm was has been in the use since 2011, Spark is fairly recent. Okay. Storm comes with Hadoop distribution called Hortonworks, while Spark comes with both Hortonworks, Cloudera, and MapR. Okay, so support for Storm is not available, while Spark streaming is well supported by Databricks. The resource manager integration for Storm is Mesos, and for Spark streaming, it runs on Yarn. Okay, so I think the now Storm also runs on Yarn. So in summary, Storm has been in production much longer than the Spark, and however, Spark streaming has advantage that it has a company dedicated, and second, it is compatible for Yarn. I think they have moved Storm also to the Yarn, so last point is not valid. So you can go with these slides and do a comparison. As a thumb rule, if you need the processing at a sub-second level, then you go with the Spark. Otherwise, sorry, then you go with the Storm. Otherwise, Spark streaming is good. All right. So now we'll just go through quickly through these NoSQLs. All right. And then we'll discuss the project. So Mahesh's question is, why is it faster and how? Because it has been designed bottom up just to process records in really, really fast time. While Spark has been designed for kind of making the batch processing faster. And later on, people realized that that could be used for streaming. All right. So it's basically certain design decisions because of which the systems differ in their speed. All right. So Yessi's question is, so we need to know what data we need to feed for a particular algorithm and the format. Yes, we need to know that in case of Mahat. All right. So let me just go through quickly through various databases because these questions will keep coming to you. It's very important to know what databases, which database does what. So Redis is an in-memory database. Although everything which is in Redis is also backed up in the disk, but Redis keeps everything into memory. If you have huge data that can't fit into memory, then you will be in trouble. You won't be able to use Redis for that. Though Redis is extremely fast, extremely fast. It's good for rapidly changing data with a foreseeable data size because it won't fit into the memory, then you can't use it. All right. So Redis is good for storing real-time prices, real-time analytics, leaderboards, and real-time communication. And wherever you used Memcached before, you can use Redis for that. Next is MongoDB. It's a document-oriented database. Document means it's a JSON, so each document might be very complex as shown in the figure. Okay, the object inside object kind of documents. Document means a complex object. It's best used if you need dynamic queries and if you prefer, okay, if you prefer to define indexes, not map reduce functions. If you need good performance on a big database. In very simple word, when your data is complex and you need good performance over big database, then you should go for MongoDB. Generally, people with the CMS kind of background, content management system, they generally go for MongoDB. For example, WordPress and Drupal both support storing the data in MongoDB. Okay, for most of the things you would like to do with MySQL or Postgres, but having predefined columns is really holding you back. In those cases, you go with MongoDB. All right, Cassandra. It stores huge data set in almost SQL format. Okay, if you are comfortable with SQL kind of format, you would like to go with Cassandra. Okay, it's best used when you need to store data so huge that it on the doesn't fit on server, but still want a friendly, familiar interface to it. So you might need web analytics to count hits by hour, by browser, by IP, etc. So it's almost like SQL and is heavily load balanced. But most of the cases, if you have HBase, you don't need Cassandra. If you don't have HBase, then you might choose to go with Cassandra. All right. Now, HBase we have already discussed billions of rows by millions of columns. That is the use case. Okay. It's used by search engines. The only thing is, in Cassandra, Cassandra provides you great query language, while HBase does not. Alright, so that was an overview of HBase. If you need cell level security, you might like to go with Accumulo, and a hypertable would be a smaller version of HBase, a little faster also. So you could go through other differences at this particular URL. That seems to be good to me. Alright, I would like to go through the project now. The details of the project are available in here. You could go to the last session. and open the project discussion. And in this project, what you have to do is the statement, problem statement is you have to find out the sentiment analysis based on Twitter data. The objective of the exercise is that given a lot of Twitter data, you have to present it, you have to do the sentiment analysis. The step below outline a primitive strategy for sentiment analysis of the movie called Iron Man using Hive. So it is up to you whether you want to use exactly same steps or different strategy altogether. There are various deviations possible. For example, you could use pig instead of hive, although I will be giving, although we have given you the strategy, but it's a very basic strategy. You could come up with a better strategy. Okay, so the other variations which you might try is number one, you could use pig instead of hive, or use a completely different algorithm. Maybe you can compute the sentiment based on natural language processing. Use your own Flume pipeline to download data. Okay? Right now, we will be providing you the downloaded data. It's up to you how to, whether you go with this one or you download your fresh. Or you may want to create your own program to download data from Twitter, or you can also use a different visual representation than the Excel. You could use D3JS, or maybe Tableau, or maybe BERT. All right. So you can log in into Hue from this URL, locate the data which is located here. Okay. You can see the data here. And this data is in the format, so you can see tweets raw. It contains the gzip folder like this. Okay. And then you have the time zone details. Then you have dictionary. Dictionary gives you the polarity of each word. Okay, so go through this particular example, and it's also, yeah, once you have gone through the data, go through the example query which we have given, and before you start your own database, you have to create your own database. Okay, you could go here and check it out. So this is the query. Okay, this is the query using which you will have to utilize, using which you can generate the sentiment analysis. Okay, so first of all, you download this JSON file, and also you can copy the sentiment files into your own folder, or you can directly use from here itself. All right, and then you set this reserved keyword false and add this jar to the path. Once you have done that, and you create the database name and use your database name. After that, you load the tweets raw into an external table from this location, okay, whatever location you have given here. And then you create an external table, okay, you create external table called dictionary from this particular location, okay, and then you create another external table called time zone map, and so on. Okay, when once you have created this, you go through these queries and understand how it's generating the generating the sentiment analysis. In very simple words, we are going to break down each tweet into one word per record, and once we have done that, we will find out the sentiment of each word. And once we have found out the sentiment of each word, then we will sum it up all, so that we know per tweet what is the sentiment. Is it negative or is it positive? And then once we have done it, we will represent it graphically, saying these many tweets in this region and this much positive or negative sentiment. All right. So you go through this. It should give you a fair amount of details on how to create the data. The final outcome of this SQL is tweets BI, which contains the sentiment and rest of the columns. And once you are done with creating tweets BI, then you install Hottenworks Excel driver, and then you configure your Excel sheet spreadsheet to talk to the Hive server. Okay. All right. So All right, so that's pretty much about the project. Please submit it. The timelines are as follows. Timelines are here. Okay. So actually the end date is 7. We have to make it 7, and the submission date is what do you call the 14th February. All right. Assignment submission is 14th February, and project submission is 21st February. All right. That's pretty much regarding the project. All right. So, all right. So, thank you very much. And I would like to unmute you if you want to do so and say hello before the last session. All right. Yes, is it okay to unmute you? All right. Let me unmute Abhay. Okay. Hi, Abhay. You are unmuted. You can.
Hi Sandeep, can you hear me?
Yes, I can hear you, Abhay.
Oh, great. Um, so you would like me to introduce yourself, or
Uh, I,
what are we?
no, I'm just saying, I mean, goodbye. That's it.
Oh, okay. Yeah,
Okay.
sure. It was great, and it was very helpful um, for the entire session all this while, and I'm looking forward to complete the project as well. But I will let you know wherever I get stuck, and will appreciate any help in that regard.
Great, 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 great. Sure, sure. We will try to help you out as much as we can. Okay. And also stay all of you stay connected to us because we are working on a couple of good big data projects. So we may like to use you. We may like to have you on board. All right. And I have unmuted you, Biswa. You would like to say something?
Hi, Sandeep and the team, and I'm pretty happy that you took so much of pain to clarify all our doubts and gave us a new direction. So I'm really, I would appreciate your contribution to our knowledge, basically for me. And I'm a pretty senior database engineer, and yeah, it helped me a lot to understand the big data concept, and moving forward in my career, I would definitely do something better in big data with your suggestions and with your teaching also. So
Great,
thank you very much.
great, Biswa. All right, all right, great. So stay connected, and if you have any doubts, just email us. All right. And Yash, I'm unmuting you now. Okay, you're unmuted.
Yeah, the training was fantastic. I enjoyed it a lot,
Okay,
and I hope to stay in touch with you in the future. So, uh, if
all
I
right.
get an opportunity, put would like to participate in some project.
Great,
Thanks.
great, great. I look forward to it. I look forward to it. All right. All right. Mahesh, Mamta, and Murli, and Midli, and Prezi, can I unmute you also? Yeah. Okay. I'm unmuting Mamta. Yeah. Go ahead.
Hi, Sandeep. Hello, all. It was a great session, Sandeep, and it was very I mean, you're very knowledgeable, and your teachings were very good. Uh, Thank you for your time because you took more than 6 weeks to complete it, and you answered all our questions. And I would like to stay connected. Thanks a lot again.
Okay. Great, 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 Mamta. Uh, yeah. I actually like this batch particularly because you guys have asked great questions. All right. I'm unmuting you, Mahesh, now. All right. I have tried to unmute you, Mahesh. All right. So Murli or Prezi, do you want me to unmute? Yeah, you're unmuted. Mahesh?
Hi Sandeep, thank you very much for all your sessions and the patience in answering our questions, and thanks to everyone who participated with good questions. It has helped me a lot. And as I mentioned in the beginning of the class, I stopped programming long time ago, but I am into management now.
Okay,
So
interesting.
my company is bringing in big insights
Okay,
from IBM.
okay,
So I'm managing that right now. So I
okay,
wanted to learn more about what Hadoop is and what the technologies are on.
okay,
So I will be looking forward to some good Hadoop programmers soon
okay,
once we complete the IBM cloud environment setup.
okay,
So if you have anybody looking for, and especially in US, please let
okay.
me know.
Oh, great,
Yeah.
wonderful, wonderful.
So, and again, thank you very much for your patience and answering questions. And I'll be in touch with you. I'll try to do a lab. It has been a long time programmed, but I will try one.
Okay, okay, great, 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 great. All right. So it's wonderful to have such a great team, and we look forward to work with you. All right. All right, Murli, now I'm unmuting you. All right, go ahead, please.
Yeah, hi Sandeep and team. Sandeep, I attended few classes, so maybe I have to take another session.
Okay,
So, but whatever sessions I have attended, it's too good, and I've been recommending to other my friends too.
okay,
So,
okay,
actually, resume I have got better understanding.
okay, okay,
So,
okay. So actually, I was
but
wondering because for next session, I never advertised. I did not even put my Google Ads or anything, and my classes
okay.
are overbooked as this next one, which is starting. So
Oh,
I was planning that this session would be my last, and I will not give any more sessions. But it so
okay.
happened that the class is full without even advertising. So
Oh,
I'm not supposed to stop anymore. So that's the thing.
right.
Okay, so it's
Yeah,
because of my students' feedback, like you, that people are,
right.
yeah. All right, great to have you, Murli. It was a great session and great set of team. And all right, I'm unmuting Prezi now. All right, I've unmuted you.
Hi Sandeep.
Yeah, yeah.
Uh, Murali is the one advertised to meet you to join
Okay,
this
okay, okay,
session.
okay,
So very good and very much thankful to you. And I'm looking forward to jump into this career. So far, I've been a Java developer, so I'm going to start my career with Hadoop.
okay.
And these are going to be really helpful to me. I have a question. So do we get access to this CloudX lab even after this project
Yeah.
submission?
Yeah, up to only this batch, up to your batch only. I have kept the sessions open for up to March. Okay. In future, since we are selling the CloudX Lab as well as a separate product to many other instructors, in other batches are that the flexibility is not going to be there. But for the current batch, it's going to be up to March. Okay.
Uh-huh. Okay.
If you
And
want in
also the
future, you can renew. Okay.
oh, okay, that's great.
Yeah.
And the tutorials, everything would be available for us anytime to access, right?
Yes. As long as my company.
Whatever the recorded sessions are.
Yeah, as long
Mm-hmm.
as my company is running, these will be available. All right.
Okay, thank you so much. I'll get in touch with you.
Great.
Thank you.
All right. So, all right. And all right. So I think I have unmuted everyone except Midley. So yeah, March end till March end, Abhay, the CloudX lab will be available to you. Okay, and Mamta, the price, we have not decided the price for our students so far, but we will let you know. It will display on cloudxlab.com's website. All right. And there was a question from Mahesh. Do you teach or consult work for full time? So no, I don't have a full-time job. I'm working mostly on CloudX Lab and I'm partly contributing to these open source projects such as Cassandra and others in Hadoop ecosystem. And I plan to work mostly on the big data part. All right. So, okay. So stay connected and you can send me a LinkedIn request so that we are well connected. And although these days it doesn't make much sense to say goodbye because we know that we'll be connected. Yeah. So yes, Biswa, we can have a discussion on the certificate, right? So Mahesh's question is, do you provide on-site classes? Right now, I'm avoiding on-site classes. Unless somebody puts a gun on my head, I don't go for on-site classes. Yeah. All right. So great to have you in the session and stay connected. Feel free to reach me out at Sandeep at No Big Data. Sandeep at No Big Data. That's my ID. All right. For any commercial or any other thing, like you're referring somebody, just put mail to reach us at No Big Data. This is my personal one. For any technical question where you want specifically me, I can talk to you. For other things like regarding course or classes, if you want to move to other batch, just drop a mail to reach us. All right. So great to have everyone in session. All right. Bye bye for now. Have a great day.